So I think the answer is 0. Shivani, nonetheless, let's do it. According to the definition of the derivative, this says what? The limit h goes to 0, f of x plus h minus f of x all over h. Kind of just writing that out every time for a while. So this would be the limit h goes to 0 of what? What is f of x plus h?
C.
Yeah, Laura, this is just a constant function, right? Anytime you plug anything into it, you just get back c, right?
Yeah.
Is she crying with embarrassment into her arm? Cool. What happens when you plug x in?
C.
Yeah, you get c. And then over h. Okay, so what is this limit?
0.
Over 0.
No.
0 over.
I don't know.
Yeah, okay. So yeah, don't be confused. This is not a 0 over 0 situation.
0 over a really small number.
Yeah, because this is not a 0 over 0 situation. This is actually 0. Remember, 0 over 0 situation means almost 0 over almost 0. This is not almost 0 over almost 0. This is actual 0 over something which is very tiny. And thus the answer is 0. Okay, just as predicted, so no surprise there. And if there's no surprise, then there's no information value in having done that at all.
Wait, why do we?
Well, now comes something bold and wonderful, truly wonderful. Here's a rule, what is the derivative in general of x to the n? I'm seeing right now that we're just going to drastically not finish this lecture.
Drastically.
I called it.
No, yeah, I know. I think I'm just gonna videotape 9th period's version. I think 9th period is gonna make it a surprise appearance in this video series.
What?
And then you guys are gonna have to watch for like 20 minutes. Because I mean, I have enough time to like squeeze in the bare bones, but like the exciting like discussion afterward is not gonna happen. So that's what's gonna. So you guys might have to watch like some video for like 10 minutes over the weekend, like 15.
Over the weekend?
Over the weekend.
Usually the pesticide.
Imogen, we're going to do this now. Go.
You're great. You go for like.
I need to have a serious talk about that.
Isn't it just like one? Is it just one? Is it just one? Triple? Or no?
I need to talk to her. Oh, you can just pan around and watch all the smiling face.
No.
Actually, don't do that. So yeah, these are called power functions, and we're just going to do this. Once and for all. Yeah.
Is there a reason you're using all the h form of this derivative thing? Or you're using the h one
As opposed to the a one. Yeah, both are possible. I'm going to do it with the h way this time. I was actually going to do both. That's probably what we're not going to run out of time for. Is that?
we're not doing it. He says he is doing it.
Oh, it's the end part. No, because then okay, so actually I have like
So
squares like plus.
in general, it's always just this, and so within a couple seconds you end up like x to the x plus h. Yeah, x plus h. Yeah, to the n minus x to the n all over h. The hell do I do now?
Multiply it out.
Oh yes, Kendall. Oh yes. There's pretty much only one thing to do now, right? What can you do?
Binomial theorem.
Yeah, you have to expand that out somehow, right? Just like over there we had a quadratic, the only thing to do is to just expand it all out. So what do I have to do here? I have to expand it all out. If only you had had a pre-calc C teacher who had taught you exactly how to do this.
If only.
Yeah.
Oh well. That's what he's having to say. I don't know what to do.
Yeah, and then Taylor was like, too bad we didn't. This is like too much. I was like, I know. It's like X and 0, H to the N, and then X equal 1, and it's like, it's infinity.
No, it's like N
Dot, yeah. Which is what no one has time for. What?
Anyways, dot, 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 it's just like, but you know, you only care about one person. So then choose one, like you have like some learning over being.
Are you guys doing this? Is it working?
So it's like H to the N, right?
Just do the binomial theorem. Just
Hold
go.
on. Okay.
Help each other.
What are we doing? Like that, and then like, and then minus X to the N.
So it's like, yeah, it's like n choose 0, h to the n, h to the 0, n to choose 1. But you know,
Oh wait, it starts with N.
Dude, dot, dot, dot.
I mixed up. I thought it was X to 0, then
This is how we always did it, right? Remember, because it's like how many x to the n, h to the 0 terms do I have? Answer.
As much as you want.
Not as much as you want. Just one. The number of ways of going left n times and right 0 times, of which there was only one way. How many x to the n minus 1, h to the 1 terms do I have? The number of ways there are to go left n times and right only once. It's coming back to you ish a little bit?
I mean,
Ish.
you know.
How many x to the n minus 2 h squared terms? Well, the number of ways of going left twice, the number of ways of going left twice and right twice and left all the rest. So that's n choose 2. And then I'll just kind of like throw in some dot, dot, dots, and we get to the last one is going to be,
X to the N.
maybe we'll do second to last
Oh yeah,
one.
second to X to the
N choose n minus 1. X to the 1, h to the n minus 1. Is that right?
Yeah.
And the last one will be n choose n, which is just 1,
H to the N.
h to the 0, h to the n. I think that's good.
Yeah.
All of that's just the binomial theorem applied to
minus
this
X
thing.
to the N.
And then minus x to the n.
Which that
Over
first thing
H.
All over h.
Yeah.
But that last x to the n just gloriously cancels
Cancel.
this first one because n choose 0 is just 1.
Then you can divide everything with the
Gloriously,
H.
that's a nice word.
Thank you. And so all the rest of these have
An H.
an h in them, right? So this is the only one that didn't have an h, because h to 0 is really just 1, but it canceled with him, and the rest of these all have h's, so now this becomes the limit, as h goes to 0 of, you guys did this already?
Yeah,
It's like better if you're like already done.
Wait.
It's no fun if I'm doing it for you.
So H, then you take out all the H.
Yeah, and what does n choose 1? Just like reminder. N. So it's n x to the n minus 1. Now I divide every term that's left by h. So that's gone, and now plus n choose 2, x to the n minus 2, h to the 1. Plus n choose n minus 1, x, h to the n minus 2. But as some of you realize, this is all kind of like irrelevant because when I take the limit,
H is just equal to 0.
any term that has an h in it just dies.
Yay.
Wow. Holy crap. The answer to this is nx to the n minus 1. Raven, this is amazing. This has a name and it's called the power rule. And the power rule enables you to take the derivative of any power function. Gehard, let's do one. Ready? What is the derivative of x to the 4th? You have a choice. You can either use the so-called definition of the derivative, make a giant thing, expand it all out, or apply the power rule. Answer, Gehard.
What?
4x cubed. So easy, so simple, so wonderful. Okay, now I'd like to make some deep thoughts. So I am going to connect this to something that you already knew. The truth is that you had this information in you all along, to some extent, because you did this unit back in Pre-Calc B, this data analysis unit. And one of the objectives of the data analysis unit was that you analyzed patterns in functions, and you saw things. Like, for example, take the function f of x equals 3x. That is a linear function, and we can make happy charts. So here is a happy chart. I keep saying happy because Giles keeps saying stupid. Do you ever go into this stupid chart, stupid triangle, stupid doing something? I got in a fight with him the other day. I was like, stop calling everything stupid. That's why I call everything happy. I started doing that because of him. All right, so we make a happy chart. So let's plug in a bunch of numbers like 0, 1, 2, 3. If you plug in 0, what do you get? Fast.
0.
0.
3.
I'm not any nicer than him. It's just a matter of language. Okay, so if you plug in 1, what do you get? 3. 3, 2, you get 6. You go. Okay, great. Let us analyze this data, shall we?
Sure.
As I go up by 1 in my inputs, what is happening to my outputs?
Go up by 3.
They're going up by 3. Damn. Okay, this is like 6 weeks of Algebra 1 is spent getting you to understand this concept that linear functions increase at a constant rate. Right? Say right.
Right.
Okay, good. Let's take it up a notch. Now we're at the level of Algebra 2. Take a quadratic function, 2x squared, for example, and now let me again plug in 0, 1, 2, 3, 4. Okay, if I plug in 0, I get 0. If I plug in 1, I get 2. If I plug in 2, I get 8. 3 is 18. 4 is 32. Okay, let us now analyze what is happening to my y values, where they're going up 2, up 6, up 12, and up...
Wait, 12? 10.
Probably 10 would be the right answer. And then up, what is that, 14?
Yeah.
Yeah, 14. Okay, 2, 6, 10, 14. Does that look familiar at all to you?
Yes.
Those are all numbers.
They are all numbers, Teo. But what about those numbers? Yeah, well, look. 6 is 4 more than 2. 10 is 4 more than 6. And 14 is 4 more than 10. In other words, the numbers which are describing the rate of increase of this quadratic are themselves increasing. And at what rate are they increasing? At a constant. Well, these numbers are increasing at a constant rate. So what I know about lines is if these numbers 2, 6, 10, and 14 are increasing at a constant rate, thus these numbers are linear. And thus what this tells me on some very deep level is that quadratic functions grow at a linear rate. Follow? Okay, am I done? No, of course I'm not. I think everything until it's to the level of ridiculous. Slash awesome, same thing. Let's take the function f of x equals x cubed. 0, 1, 2, 3, 4. Big numbers coming. Let's see if we can handle it. Yes, we can. This is 0, this is 1, this is 8, this is 27, this is 64. Let us analyze the data. By how much is this cubic increasing?
1.
1, then
7.
7, then 19. 19, right?
Yeah.
19, then 37. I do not recognize those numbers at all.
Yeah.
Let's see what's going on with these numbers. Well, these are going up by 6, by 12, by 18. Haha, I'm on the trail. 6, 12, 18, that certainly looks familiar. They are each going up by 6. Okay. In other words, what I'm saying is the numbers which describe the rate at which this cubic is growing are themselves growing. At what rate are these numbers growing? Well, they're growing at a rate which is linear, right? So since this is constant, then these guys are linear, then these guys are quadratic. Did you do this maybe for like a second in pre-calc B?
Yeah.
Okay, so Mateo, this is what this says. Oh, and by the way, there's another piece to the puzzle, which is I could give you just like a constant function, f of x equals 5. And we can make a chart. This one actually is a stupid chart. So if we go 0, 1, 2, 3, this is just like 5, 5, 5, 5. It's going up by 0, going up by 0, going up by 0. Okay, guys. Constant functions grow at a 0 rate. Linear functions grow at a constant rate. Quadratic functions grow at a linear rate. Cubic functions grow at a quadratic rate, etc., right?
Yeah.
Every polynomial grows at a rate of a polynomial of the degree less. This is the informal version. This is the formal version. That's what the derivative says. That's what this derivative formula tells me. The cubic is growing. That function f(x) equals x to the fourth, for example, is growing at the rate for a cubic. Sandeep will be crouching in the fetal position in the hallway on the way to Spanish. Okay, guys, as far as we got, lecture to be continued in period 9. Internet, you're going to get a view of my other class. What? Oh yeah, I need the homework too, and then I will see you later, and then we have a test on Friday. Yes.
What's the difference between a constant function and a cubic?
They are kind of different for these kind of reasons, right? Sort of.
Actually, does, yeah. Yours kind of bad. Constant function